All right, let's jump into the world of AI and these incredible demands that AI is putting on memory technology.
Yeah, it's really amazing when you think about it, like the amount of data these huge AI models need to process quickly. It's really pushing the boundaries of what we can do with memory.
Yeah, it's like we're trying to, fit a library into a tiny little box.
Exactly. And right now the main solution that's being used is high bandwidth memory HBM, but it has some downsides. It's really expensive to make. It uses a ton of energy, and the manufacturing is so complex that, you get a much lower yield of usable chips compared to just normal DRAM.
So HCM is like the fastest thing out there,
Yeah.
but it sounds like it comes at a pretty steep cost.
Yeah.
I mean, both literally and in terms of how much energy it needs. But, in AI, I thought speed was king.
Yeah, that's true. But there's a catch. A lot of the work that AI does, especially things like inference, where the model is analyzing new information, based on all the data that's been trained on that doesn't really require super fast write speeds. It's really about reading that data quickly.
So it's kind of like using a rocket ship to go to the grocery store.
Exactly. Yeah, you get there really fast, but you're using way more fuel than you need. And this is where it gets interesting. Researchers have proposed a new type of memory called managed retention memory, or MRM. And it's really designed to find that sweet spot for AI by, focusing on the things that matter most.
Okay, I'm intrigued. Tell me more about MRM. What makes it so different?
Well, the really clever thing about MRM is where it sits on the memory spectrum. It's kind of in between your typical DRAM, which loses all its data when the power goes out, and the, really long-term storage, like your traditional storage class memory SCM.
So it's not just about speed or about, how long it can hold on to data.
Yeah.
Then what is it optimizing for?
Well, think about it this way. AI models don't really need to store data for, years and years. Typically, just hours or a few days is enough. So MRM takes advantage of that. It kind of relaxes those requirements for long-term data retention and instead focuses on the things that AI really needs, like fast reading, being energy efficient, and higher density.
Hold on, did you say higher density than DRAM? How's that even possible? I mean, DRAM is already super dense.
Well, here's the key. MRM is really built around how AI works. A lot of what AI does involves accessing data sequentially, like reading things from a list one by one.
Hmm.
And MRM uses a method called block addressing, which is really efficient for that type of access.
So MRM is not just about being fast. It's about working smarter, not harder, by, really optimizing how AI uses data.
Right. And that actually leads to another really interesting advantage: endurance. You can kind of think of a memory cell like a light switch that you can flip on and off. And endurance is basically how many times you can flip that switch, before it breaks down. And AI is constantly reading and writing data, so you really need memory that can handle a ton of those cycles.
Yeah, okay, that makes sense. But so where does MRM fit in when we're talking about endurance?
Well, on one end of the spectrum, you have HBM, which is built for extreme performance and it has incredible endurance, but it's way more than AI really needs. On the other side, you have like the current storage class memory devices, and those just don't have the endurance to keep up with, all the reading and writing that AI does.
Yeah.
So MRMs could really hit that sweet spot. Enough endurance for AI workloads without, going overboard like HBM.
So it's all about finding that, that perfect balance, the Goldilocks zone of memory, so to speak.
Yeah.
But is MRM like tied to any specific technology yet?
Well, that's what makes it so exciting. It's not about one specific technology. It's really a whole new approach to thinking about memory. It's kind of like a blueprint, but we're still figuring out the best materials to build it with.
Okay, so what kind of materials are we talking about? What are the contenders for actually building this revolutionary memory?
Well, there are already some promising candidates out there. Things like MRAM, RARAM, PCM. These have all been explored for SCM, but they could potentially be adapted, to fit that MRM profile.
So instead of trying to make them hold on to data for
Yeah.
years at a time, we could optimize them for shorter retention, but with like way better performance and energy efficiency.
Exactly. It's about recognizing that AI has its own specific requirements, and MRM is designed to meet those needs directly rather than trying to be a one-size-fits-all solution.
This is really exciting stuff, but let's talk
It's
about the bigger picture for a minute.
Yeah.
If MRM actually takes off, how could it change the world of AI?
The potential impact is enormous. If we can create memory technology that's more efficient, denser, and really tailored to how AI accesses data, it could remove a major bottleneck in AI development.
So we're talking about like faster training times, more complex models, maybe even completely new AI applications that we can't even imagine right now.
Absolutely. It could really be a catalyst for the next wave of advancements in AI, and that could have ripple effects on everything from scientific research to, personalized medicine to self-driving cars.
Wow, it sounds like MRM could really change the game for both the performance and the accessibility of AI.
Yes, but, and this is important, realizing MRM's full potential is going to take a real team effort. It's not just about building the memory itself, but also developing the controllers that go with it, the software that interacts with the memory, and even adapting AI algorithms themselves to take full advantage of this new way of doing things.
So it's a multifaceted challenge, but with potentially huge rewards. It's like, launching a space mission. It requires expertise from so many different areas,
Yeah.
but the payoffs could be astronomical.
That's a great analogy. And speaking of expertise, collaboration is going to be absolutely essential. We need material scientists, computer architects, software engineers, AI researchers. Everyone needs to be on board.
This really feels like a pivotal moment in the history of technology. Like we're on the cusp of a major breakthrough. It's exciting and maybe a little bit intimidating too.
It's definitely a thrilling time to be working in this field. We're not just
Sure.
watching the future of AI unfold, we're actually shaping it.
Right.
And for those of us who are really passionate about the possibilities of technology, it doesn't get much better than this.
Okay, let's bring this back down to earth for a second. For listeners who maybe aren't deep into the world of AI and memory technology, what's the key takeaway they should remember from all of this?
I think the main message is that AI is really pushing the limits of what we can do with memory technology. And this search for better solutions is leading to some really groundbreaking ideas.
And MRM is at the forefront of that search. It's really a call to action for the whole tech industry to come together and make this vision a reality.
Exactly. This isn't about making small improvements. This is about fundamentally rethinking how we store and access information in this new age of AI.
That's a powerful thought. But what about the timeline? Any idea of when we might actually see MRM in action? Like in real AI systems. So MRM, it has the potential to revolutionize AI, but when can we actually expect to see it, out in the wild? Is this something that'll be, in our smartphones next year, or are we talking, decades down the road?
Well, predicting the future of tech is always a little tricky, but the excitement around MRM and how quickly research is progressing, I think it's possible that we could see early prototypes maybe even within the next few years.
Wow, that's a lot sooner than I expected.
Yes.
So we could be looking at, AI systems running on MRM within this decade. That's pretty amazing.
Yeah, it's definitely a possibility. Of course, taking something, from a research concept to, a mature technology that everyone's using, that always takes time. There will be, engineering challenges. We'll need to, develop industry standards and so on. But I think the potential benefits are huge. So it'll be worth it.
Yeah, absolutely. I mean, when you consider how much this could impact AI development, it seems like a no-brainer to really invest in MRM.
Yeah.
But will this just, make AI faster, or are we talking about something that's more transformative?
I think it's more than just, playing catch up. I think MRM could really open up a whole new world of possibilities.
Yeah.
Enable AI applications that we can't even imagine today.
So a fundamental shift in what AI is capable of, like what kind of applications are we talking about?
Well, imagine, hyper-personalized medicine where AI can analyze your, unique genetic makeup and your lifestyle to create custom treatments, or picture self-driving cars that can navigate, really complex environments with almost human-like intuition. Those are just a couple of examples of what MRM could enable.
It's starting to feel like, the dawn of a new era for AI. Like we're
Yeah.
standing on the edge of this unexplored territory, just full of potential.
I think that's a great way to put it. We're on the verge of a real transformation in computing, and MRM has the potential to be, one of the driving forces behind that change.
Well, it sounds like we've only just begun to scratch the surface of what MRM could mean for the future of AI. As we wrap up here, is there one final thought you'd like to leave our listeners with?
Sure, here's something to think about. If MRM can bridge that gap between, memory and storage, what other boundaries could we blur in the future? What other innovations might we see when we start to question those traditional assumptions about how computers work?
That's a really great question.
Yeah.
And it reminds us that we're living in a time of incredible technological advancement. The possibilities really are limitless. Thanks for joining us on this exploration of AI memory. And until next time, keep those minds curious and those imaginations firing.